Here we have AP calculus AB problem. Okay, let's go with the information. Find the x values of all points of inflection of the function f of x equals to x to the fourth power negative 6 times x to the third power. So according to the question, for this function, we have to find the x values of all points of inflection. First, let's understand what is point of inflection. So for example, let's consider in a particular interval, the curve is concave upward. In a particular interval, it's concave downward. Like say a particular value over here, say x is equal to a. At this value, the curve changes from concave upward to concave downward. So at the point, at the value of x where the curve changes from concave upward to concave downward, or sometimes it will change from concave downward to concave upward. So that is called point of inflection. So in this example, the given curve changes concave up to concave down at x equals to a. So this is the value of x at the point of inflection. Okay, so how do you have to find the value of this x at the point of inflection? So for that, what we have to do is we have to find the first derivative and the second derivative of this the function, and then the second derivative has to be equal to 0 and solve for x. Okay, first let's find the first derivative. For that, let me write the given function as it is. It is f of x equals to x to the fourth power negative 6 times x to the third power. Let me find the first derivative. So we can use the power rule of derivative to get derivative of this one. That is, we have to bring the exponent 4 in front of the variable x and subtract 1 from the exponent. So negative. Here there is a constant multiplied by the variable. So when I find derivative, if there is a constant multiplied by the variable, I have to keep the constant as it is, and I have to find the derivative of the variable part. So here we can find the derivative of x cube using the power rule of derivative. That is, we have to bring the exponent in front of the variable and subtract 1 from the exponent. Then I'm getting 3x square. So let's simplify this one. F prime of x equals to 4 times x to the third power. Negative 6 times 3 is 18 x to the second power. Okay, now I got the first derivative. Now I have to get the second derivative. That is f double prime of x equals to. So it's a constant multiplied by the variable. Let's keep the constant 4 as it is. When I find the derivative of this x cube, it will become 3 x to the second power negative. So 18 is a constant. When I find derivative of this x square, it will become 2x. F double prime of x equals to 4 times 3 is 12x square, negative 18 times 2 is 36x. Okay, now what we can do in the next step is we can factor this expression. Let me write f double prime of x equals to. So the greatest common divisor of 12x square and 36x is just 12x. So we can factor 12x out. Now to get the stuff inside the parentheses, we have to divide the terms of this expression by the 1 I factor, that is 12x. When I divide the first term 12x squared by 12x, I'm just getting x negative. When I divide this 36x by 12x, I'm getting 3. Okay, now I factor this expression over here. So in my next step, what I'm going to do is I'm going to equate this second derivative to 0. So when I do so, I'm getting 12x times x negative 3 equals to 0. So here we can assume this is one term, this is another term. So the product of two terms equals to 0. Whenever the product of two terms equals to 0, either the first one has to be 0 or the second one has to be 0, or both of them may be 0. So first one may be 0 or the second one may be 0. So equals to 0. Now let's solve for x in this one. For that we have to get rid of this 12 which is multiplied by x. For that I have to divide both sides by 12. This 12 will cancel. I'm getting x equals to 0. 12 is 0. Now let me add 3 to both sides. When I do so, this negative 3 positive 3 will cancel. I'm getting x equals to 3. Okay, when I equate the second derivative to 0, I'm getting two values of x equals to 0 and x equals to 3. Now let me mark these two values on the number line. So the left side extreme over here is negative infinity. This is a real number line. And the right side extreme is positive infinity. So I have 0 first and then we have 3. Okay, now when I mark these two values 0 and 3 on the real number line, I can split up the real number line into 3 intervals. There is negative infinity comma 0 is the first interval, 0 comma 3 is the second interval, and 3 comma positive infinity the third interval. All of them are open intervals. Okay, now what I have to do is I have to check each of these 3 intervals with f double prime of x. So what I have to do is I have to check whether f double prime of x becomes positive or negative in each interval. So for that, what we have to do is we have to take a random value in each interval. Let me consider the first interval. So the random value, what we can have in this first interval is, I think it's negative 1. So now what we have to do is we have to plug in this negative 1 into f double prime of x, and we have to check whether it's positive or negative. When I plug in x equals negative 1 over here, so 12 times negative 1. When I plug in -1, -1, -3, it will become -4. So 12 is positive and -1 is negative, -4 is also negative. So positive times negative is negative, negative times negative becomes positive. So in the first interval, there is in negative infinity comma 0. So f double prime of x is positive. Okay, now let me take the second interval, that is 0, 3. Now let me take a random value in this interval. So I think we can take 1. So when I plug in x equals to 1, let's see what's the sign of f double prime of x. So 12 times 1. When I plug in x equals to 1 over here, 1, -3 is a -2. This 12 is positive. This 1 is also positive. And this -2 is a negative. Positive times positive is positive. Positive times negative is negative. So f double prime of x becomes negative in the second interval, that is between 0, 3. Okay, now let's check the third interval, 3, positive infinity with the second derivative. For that, we have to take a random value in the third interval. So we can take 4. Now let's plug in x equals to 4 into the second derivative. Then we get 12 times 4 when I plug in x equals to 4 over here. So here when I plug in x equals to 4, 4 -3 is just 1. So here this 12 is already positive, this 4 is positive, this 1 is also positive. So when I multiply 3 positive signs, the result is also a positive. So in the third interval, that is between 3, positive infinity, f double prime of x is positive. Since f double prime of x is positive in the first interval between negative infinity to 0, so I have to decide that the graph of the given function is concave up in this interval. And in the second interval between 0 and 3, since the second derivative is negative, the graph of the given function has to be concave down. And here in this interval 3, positive infinity, again and second derivative is positive, so the graph of the given function is concave up. Okay, so when the curve is passing through x is equal to 0, it changes from concave up to concave down. So clearly x equals to 0. At x equals 0, we have a point of inflection because the curve changes from concave up to concave down. And also when the curve passes through x equals to 3, so it changes from concave down to concave up. So we have another point of inflection at x equals to 3. So these are the two values of x at the point of inflection. So there are 2 points of inflection for the graph of the given function. At those 2 points of inflection, the values of x are 0 and 3.